The problem with checked exceptions in Java. Let's get into it. Hello, I'm Chris Athanas. I'm a KMP developer, and tech support says they're gonna come out and get that thing closed finally. Yeah, so I'm gonna do a quick review of this thing about problem with checked exceptions. I never used checked exceptions too much. It was sort of on the way out when I started getting back involved with Java doing Android development. But there was always in there in the background. I was like, what is a checked exception? It's this things or exceptions that are either caught or declared the method or signature that feels secure. Okay, this is not useful. Basically, it's like in the declaration, you say you're going to tell the compiler all the exceptions that may be caused by that particular function. All right, then they thought it was really gonna explicitly handle and cover exceptional conditions for a program that can anticipate. It's like there was a lot of things that were trying to like reduce the amount of errors that were happening, especially in the early days of Java, and it's saying something has gone wrong in code and potentially recoverable, as opposed to an irrecoverable error. Okay, so they're trying to thread this needle of these two different ways. And unfortunately, it just didn't work out there. It was just poorly formed idea. And this comment right here, where is it? This one right here. This comment right here talks about why it was supposed to be used, and it was supposed to be like a way to clean up like libraries. Like the library would let you know what the exceptions were, but nobody followed it, and nobody really adhered to it, and Kotlin dropped it. So let's. I want to get into a little bit of things about some of these things that happen in software development that seem really, really good at the time. They're going to solve all the problems, but it inevitably causes another set of problems that were not seen ahead of time, and made things very painful for many people. So it was I know that the impetus of it was good, but the implementation was terrible. Let's get into it.
I'm increasingly of the mind that if you can't change your software, then the software is low quality. That is the practical, pragmatic realization of quality in your software. I don't care about anything else. I don't care what language it's in. I don't care what. If I can change it easily and safely, then it's good quality. And pretty much. And there was, and again,
that's the real key. If we're talking about this exception stuff, really the thing about this is we're talking about the goal is not to make it so we can't crash. We want it to be, the goal is to make it so it's understandable, extendable, and changeable without breaking everything. That's the goal. It's probably going to crash somewhere, sometime, somewhere, some way. But like figuring out why it's crashing, where it's crashing, that's the key. And make it so we can fix the crash quickly without having to understand how the whole system's put together. That's what we're trying to get to.
Some of these deep tools, things like modularity, cohesion, separation of concerns, encapsulation, abstraction, those sorts of coupling, those sorts of tools that allow us the freedom to make those kinds of moves when we realize, oh shit, we got it wrong.
Yeah, the freedom to make
the change.
And I think that's really important, because I think for me, one of those insights, or an emerging wave of insights over the years, has come from this idea. Okay, we're always operating with incomplete knowledge, so that means that whatever I'm doing is in some sense wrong. Although I think wrong is
we're always wrong until we have the perfect production version that goes through all the cycles of us fixing all the problems that we found out along the way. It's always wrong, and there's no perfect thing. This whole idea of like, we have a perfect solution, it's always going to be perfect forever. It's like, no, it's constant flux. That's why throw it away, start over. It's not bad. It's not scary. It'll go super fast, way faster than make it the first time, guaranteed.
There's too much attached to that word.
Your best guess so far.
It's my best, based on what it's we did our best job. This is what we've got, but now we've learned something from it, either because the world told us or because we learned as a result our own awareness of this. But what's interesting is you can derive a lot of the ideas that we value, modularity, loose coupling, all the rest of it, from an understanding of like, well, how would you build something if you didn't know everything?
Yes.
Here's the thing I'm not sure about. Here's the thing I'm very sure about. This thing I'm not sure about. I'm going to really ram it in there a couple times. No, loosely couple.
That's what we do. That's how we start off. No design up front. Let's start typing. Don't care about it. We'll figure it out on the way. Yes, we'll do that, but we have to have some design up front, some idea of what's happening, and an idea of like what things could possibly change. And that only comes from screwing it up a few times and going the painful, like, oh, this hurts, and trying to fix it instead of just starting over.
because this is probably going to change. Yeah, exactly. I'm going to isolate myself from that. I'm not totally sure about it. I've kind of got an idea, but I want to put a little bit of distance between this, and that distance is our dependencies. That distance is our interfaces. That distance.
But that'll make it perform not so good. Okay, you need to let go of some of that stuff. So it's actually performance is like secondary to making a thing work and all the time and be really robust and like fixable and understandable, and like people get on board to it, and you train people how to make it work, and it's like not this complicated mess that just depends on George to know how the secret algorithm that'll make it come back online.
The idea is that all of this falls out naturally when you start saying, well, you can actually, and this is, I think, is fascinating because it runs along a kind of an alternative axis. Sometimes they arrive at the same conclusion, sometimes they don't, to the traditional language of abstraction and things like that. How would you modularize? Modularize according to abstraction? Well, there's multiple ways of abstraction. We have different paradigms for that.
Yeah, for sure.
But what is interesting is going, well, how sure are you about this?
Different.
And it's just like, well, I'm not. I'm pretty sure we've done something almost identical. It's not identical, but it's almost identical. That gives us maybe high confidence, and this worked out well. That's the second bit. People normally forget that. Doing it, sometimes we get stuck in a rut. It's just like, we did this before, and how did that work out for you? Yeah, not very well, but we're going to do it again this way. It's just like, no, there's an opportunity here. And that's that idea of it's good to have a few ideas that you can trade off.
Yeah, it's okay to cut away stuff. It is. It's okay to cut back to the quick and add things on as necessary. You don't have to start with all the things and just cobble yourself and put yourself like you're running in crutches. Okay, but maybe you don't need all that stuff. Maybe you can just sprint with your. Everybody loves that sprint word so much.
Off against one another.
Yes.
But then you've got that other
idea, but sprintable.
Fear of like saying, well, let's go through this in terms of certainty. And I've done this a couple of times with people, and they're always kind of slightly freaked out because you kind of come up with a rough kind of like sketch of what you're going to do, and they say, well, hang on, but we haven't actually talked about all of the design detail that they normally talk about. It's just like, well, yeah, what we did is we've just drawn a bunch of boxes and lines and things based on your confidence. In other words, when I've asked a question, and you've said, oh, yeah, we're not really sure how we're going to do it. Right, I've drawn a line. There's a boundary there of knowledge because we're sure about one side, but we're not sure about the other. I don't care what it is. I don't care what paradigm we're talking. It's clearly something we're not sure about. So maybe we shouldn't hug it too closely. A little bit of looseness.
A little bit of a wall would be good.
Yeah. And likewise, when somebody says, oh, yeah, we're going to do it this way, and a colleague says, oh, I thought we were going to do it this way. You know what? There's a line there as well, because there's clearly this is not settled. And it may turn out that one of them is right one year and the other one is right the next year. In other words, things may change, whether it's performance characteristics or whatever, but favor one and then the other. And again, that's the timeful rather than timeless quality. But that idea there that we can get a heads up just by actually almost constructively using our uncertainty as a positive aspect to sort of see, well, how does this work? And then we've got the empirical side of things, which is, okay, here's what kept changing every release. What are the hotspots? What do we keep going back and saying, oh, no, this time it'll be right. We'll just add this here. And that kind of, I think one of the first times I ever really noticed that question of stability properly feeding back was a Java system. It was a company that was doing a Java system, and they had the debate about, they were having the debate and have not yet resolved it, about checked exceptions.
And man, this one does go in. So he, like this guy right here, he's like, it was supposed to be experts. Says it's sad to see supposed experts talk about this topic at superficial level. Java had clear intentions of checking. They may have had clear intentions of all kinds of things, but what can programmers do with it was a completely different thing, which is enforce checks where the JVM could not give you a guarantee of safety. There's the thing. Guarantee of safety. Where's that coming from? This stuff crashes for all kinds of reasons. Guarantee of safety. So this is the thought of that time. That was the whole. They were really going to try and solve it with this particular thing. And the reason why it's controversial, because some people really believe that it's possible to save software with using this. Okay, so the exception is best example here is the same method we call for moment this. Yes, things may fail at any time. Yes, even the checked exceptions could fail at any time. Right? It's like, in other words, it's these types of exceptions caused by externalities which don't care about your API contract. Exactly. What does in a networked environment? If everything could fail. What? If the caller breaks the API contract and provides the wrong variable, what does that mean? I don't even know how that works. The caller's a fault and you deserve a runtime error. Okay, that wouldn't happen at runtime. That'd be a compile time error. Okay, that's first of all. I don't know. Maybe this is in JavaScript. Be runtime. Okay, but then there's a host of issues that are not transparent and check exceptions. Will help you find unexpected runtime error states. Okay, I guess maybe it will. Who knows? In language without exceptions. Without the checked exception, you mean? Obviously, no documentation on exceptions where they can throw whatsoever. And it shows me it is frustrating. That's why you have a catch block and it just catches whatever the thing is. Not going to catch the particular ones that are flavor thing where we can restart, maybe not restart. I mean, we call and handle this by just having a result. That you return the value that you're expecting, or some error condition that could be exceptions are deprecated. It's like, just ease up on all the exceptions there's lots of reasons why you wouldn't have it. Now, when it's truly if there's an error condition, but then there's an exception condition where it's like, oh no, this is an unexpected error. Like if there's an error, like if you're trying to withdraw a money from bank account and you don't have your overdraft, right? That's not really an error condition, but it could be considered an exception because you're trying to withdraw with no money. So there's this nuance, right? But trying to get away from exceptions, I mean, there's reasons for it, but like if you're actually it's a normal condition of an error in the working of your program, do a result where you have you return the value or the error condition, so don't have to do these exceptions.
And for those tuning in who are not aware of this feature in Java, checked exceptions basically allow you to make exceptions part of the signature of a method, a sort of checkable aspect of the signature. And it's one of those things that in theory is a good idea, but that actually turns out that in practice, if you don't know exactly what you're doing, in other words, if you don't have perfect knowledge and you're building a large system, they have a really nasty impact because they introduce an element that is
right. You're kind of saying that these are the things that might go wrong, but there may be something else that go wrong they didn't talk about.
Unstable, or rather needs to be stable, but is not yet stable. How does this fail? I don't know yet because we haven't fully understood this. It goes right back to where we started. What are the failure modes of this? Short of saying something trivial like there is an error, and that's often what these checked exceptions tend towards, which is throws framework error. In other words, actually that's of almost no use to anybody whatsoever. Bad things may happen. Well, we knew that because this.
It seems like you're getting more defined. It's like, oh, we got this error versus this error versus this error. It's like, it seems like you're getting more refined, but it's just an error. Something went wrong, and we can give you the condition, but we don't need to know all the different ways it could go wrong. It's not that important. That's why Colin drop this stuff.
Because bad things may happen. You end up either saying nothing at all, or you'll say it so precisely that unless you've actually had this out in the field for a long time and converged on that, the chances are somebody's going to come up with a new failure mode.
Right, exactly. So that's the problem with these things is you're trying to know, you're expected to know ahead of time all these things. That was the attempt, and it's good to try this thing because like if it worked, it would have been awesome. But it didn't work, and we need to let go. That's why there's some controversy around it because it seems like it should work, but it doesn't.
And it's just like, oh, well, so the curious thing is what you've done is that your happy day scenario, what you want from the method, why the reason you called it, you don't call it, I'm not calling this method except perhaps in a test. I'm not calling this method in order for it to fail. That's not my goal here. I'm calling this because I wanted a result. I'm expecting that it's all going to work out. So therefore, right at the edge of my vision and edge of my awareness is all of these failures, all these possible failures. If we've not yet explored, and as time goes by, we get more refined understanding. Oh, this could be distributed. Oh, well, our distributed bit throws different exceptions to the ones that are those. So we've now made this thing which is local.
Is it really important to know that?
Now it's a certain,
maybe it is. Maybe it is important, and you do want to make sure that's the thing. But sometimes maybe it's not. Usually it's not. Just something went wrong. Something wrong went happen. Here's the message, and keep going.
Okay, so we're going to have to change the signature again. So we've suddenly made something. We've caused churn in the interface, and this is one of those interesting things that comes out of the kind of the more empirical side of things. It's not that nobody who put that feature in Java did so maliciously or without thought. I certainly, I certainly my understanding at the time and everything being like, no, there's some good thinking, solid thinking goes right back to the 1970s in exploring all of this. But it's the scale. What happens when you actually create open systems that are large and with all manner of developers? It suddenly turns out, there's a fundamental problem here, and it's to do with rate of change and stability of knowledge.
The rate of change and stability of knowledge. And that's why I'm always like, make the prototype, throw it away. It's because the rate of change is too high at the beginning. And the stability of knowledge is all over the place. We don't even know if this is the right, customer, even the right market. We don't even know idea. So let's not spend a long time on that until we get something that gets a little traction. And then we'll do the MVP. And then we'll do, after that, 5,000 customers, then we'll do the production version with all the bells and whistles and everything checked up the wazoo.
Do and don't know, and that was a revelation. Anyway, for this team, it was a real revelation because they were split down the middle. Half were pro, half were anti. And I just I can't go.
Nightmare. I'm glad that Colin was like, look, we're just going to eliminate this whole discussion. So you're welcome.
I mean, and just sort of say, it's going to go this way or that way. So actually came up with
again. But the only way we got there to know that that's a bad path is to go down this path and have these people have these discussions and voting and all this, and people are like, that we have to, we shouldn't, you bastards, this is going to fix everything. It's not. Like all that stuff going back and forth, just eliminate it. But we didn't know that was a problem until it became an issue, right? And then we okay, we have to solve this, and now there's a better way. They completely drop that stuff. It's like nobody's complaining. I need checked exceptions in Kotlin. Right? No one's saying that. Not one person.
Empirical approach, and I basically said, don't make anything checked. Look at, before you decide to make something checked, as it were, and seal it in. Look at how it's behaved over the last few iterations.
Write a test to simulate the failures as well.
The back end people, yes. Front end, but back end people for sure. Front end people, as the jury's out. Screenshot testing on all the happy path, unhappy path, maybe I don't know.
The failures do all of those, and they're actually quite good at that. But your understanding of the failures,
yeah,
the real
how you respond to it, absolutely.
Yeah, and it turns out that some of these kept changing on a frequent basis. And I said, look, that idea is not yet stabilized. That idea is still young. Don't nail it in place. And which is a polite way of saying, like, actually, probably, so in other words, don't make it checked until you're sure, which is a fancy way of saying don't make it checked, because the chances are they won't go back and review stuff. But what we had is at least a maturity model. And it's this idea that it doesn't matter what you think today, you're going to overvalue your confidence. And so it's this idea that time will give you the answer. I can't tell you how this is going to evolve. I can't tell you how other, this goes across API.
It could have been really awesome. Everyone was like super careful, and they just made the whole thing. Everything. It was really, and it did reduce the errors, and we didn't have to do something different, but it didn't. And now we're at let's move it on. Moving on.
Because it's not just about failure modes. How this is going to evolve. How's it going to be used? What are the things that are frequently going to change? And then go back to your point about what we want to do is align the structures of our software with what are the frequent changes we actually experience, as opposed to, people often pad their design or add complexity because they're saying, oh, well, maybe this will change. It turns out
anybody says that, maybe it will. Yes, for sure it's going to, but are we sure? Because let's just see if we can get away without doing it that way for the first thing, for the prototype, right? MVP, maybe we should start thinking about that. And when we time to get to production, you should have some of these ideas already wired out, because you did those 2 versions and you weren't afraid to throw them away because you knew you probably didn't know what the hell you were doing the first ones. And because we don't know, that's the nature of the beast.
The better your imagination, the worse this gets. So if you are a creative and imaginative developer, you can imagine all kinds of possibilities and the gold plating and the extra hooks and bits and pieces. And so the more imaginative,
out of hand. It is busy work because you can avoid the fear. The scary thing is going after the real problem, because defining the real problem is a difficult thing, and especially if we're not allowed to talk to the customer.
The less imagination you have, the quicker you'll get the job done. The more imagination you have, actually, in that sense, it works against you, because you're like, well, what about this one? All of these are possible, but most of them are not likely. And probably what you want to do is see, well, what actually happens with this? And that gets you to ask the more meaningful questions, like, well, should we release this API yet, or should we release it and put a caution on it? It's just like, okay, this is a beta release. We're not planning to support this. This is a beta release. This is for you to try. In other words, it makes us a little more aware. It makes us look up from the keyboard and go, how are people going to use this?
This clip was taken from my podcast, The Engineering Room.
Yeah, so that's go check out the podcast over Continuous Delivery, and that's some little insights about the history of some of the things that have been controversial in the past that we no longer have to deal with, and that there will always be things like this that we're talking about. Some things not as big and controversial, but there's always something. This AI stuff maybe this AI generated tool stuff isn't the greatest ever. Like they said, a lot of the code is garbage and it has to be redone and relooked at by humans, and because it was people just trusted implicitly. So there's always stuff like this. All right, give me a like and subscribe. I'll talk to you soon.